Okay, so how's everybody doing today? Bless you. It is Friday, so that's good. Okay. You're in your favorite class, so that's even better. Very quiet after I said that. Okay. A couple things. We're going to go ahead and start the fifth, 6 weeks on Monday. We're going to continue with vectors, but we're going to go ahead and stop for a couple of days and talk about vector word problems. I think that's really going to help you with some parts of your homework. Hey, thank you. Sir, she is not here today. She's not here today. That's okay. All right, so you only have 2 word problems in your homework that you picked up today, which is going to be due Tuesday, by the way. But I want to go ahead and get at least part of that lesson done, hopefully help you make a better connection with vectors, maybe understand them a little more. But the homework's due on Tuesday. We're going to go ahead and start that packet. We probably won't even begin dot products of vectors, until Thursday or Friday of next week, because I'm out on Wednesday as well for the IB meetings. Okay. And also something else that I just learned a few moments ago, I guess it's been changed. My original morning duty was supposed to be the week before spring break, the 4th to the 8th. And apparently, according to this new email, it is now going to be next week. So I'm going to see if anything can be done about that, but I may not be available for tutorials next week because apparently I'm going to be walking around the cafeteria. So that'll be super fun. One other item going on today, you may or may not have heard, during 8th period, there's going to be a fire drill. Okay, so you are going to be able to get out 5 minutes early. So at 3:50, they'll go ahead and set the alarm. Whatever class you're in, go ahead and follow the procedures. Remember, you don't stop. You're going to go ahead and keep going because you're not going to come back. But if there were a fire drill or the alarm were to go off while we were in here, what do? Go right down the stairs, past the nurse's office, right out that door to the sidewalk. Now, in a real situation, we would get the buses organized and we would go ahead and take you to a secure location. Remember that shelter on the new program that we have. If it was just a drill where you weren't leaving school, you would stay on the sidewalk away from the building because, ideally you wouldn't want to stand next to a burning building if that were the case. But that's what's going to happen today. Any questions? What about if, we're about to enter a severe weather season? Okay, so what happens if there's, say, a tornado? Where do we go if we're in here? Downstairs to the main hallway. Where in the main hallway? Okay, what's that? Away from the glass cabinets. That's absolutely right. Excuse me. But we're going to go down these stairs right outside my door. We're going to go down the hallway right below us past the computer classrooms. So at the end of the hallway on the main floor is the art office on the corner. Right there, pretty much across from the vending machines. That's where we're supposed to group. Okay. So everybody knows the location? Just in case, I'm sure at some point, with that coming up, we're going to go ahead and have a drill, one of those sometime. So that's all I have. Does anybody have any questions about what's going to be happening? Okay, then let's go ahead. I want to finish up with vectors, this first lesson, and then I want to give you the rest of the time to start working on your assignment, which is due Tuesday. And then your quiz over this material will be next Friday. Okay, will be next Friday, so a week from today. Well, we finished yesterday. We were talking about the direction angle of a vector. Now remember, a vector has to have 2 items in order for it to be classified as a vector. What am I referring to? Okay, it's got to have the direction and magnitude. Well, if you have both the direction and magnitude and you're looking to find the component form, and we've already seen over the past couple of days how useful and important the component form is going to be to us when dealing with vectors. This formula will give that to you immediately. The magnitude, remember that's the double bar notation, the magnitude times cosine of theta, and the magnitude times sine of theta. That's your horizontal and your vertical distances, your components of A and B that we've been seeing over and over again. Okay. Now remember, theta, we always start rotating from where? From standard position. Okay, so remember now, standard position when we're talking about trigonometry is the positive x-axis. But what's standard position when we're talking about vectors? What's at the origin? The terminal or the initial? The initial, there we go. All right. So we're always going to go ahead and start rotating from the positive x-axis. So let's say you do have the component form of a vector, but you want to know what the angle of rotation is to get to it from the positive x-axis. That's where this little formula comes in. Tangent of theta is equal to b over a. And again, b and a, those are the horizontal and vertical distances. Those are the components in our component form right here. So it's really, really straightforward. In fact, if I wanted to go ahead and work backwards, and if I didn't know that the angle was 30 degrees, I could go ahead and say tangent of theta is equal to b divided by a, so that would be 2 divided by 2 square root of 3. Hello. Oh, okay. Did they let you do it? To your car? Yeah. Oh, okay. All right, so you just take the ratio, and you can go ahead and simplify this. Rationalizing it would not be necessary, but how would I find theta if I did have the ratio? Starts with an I. Yeah, the inverse. Okay. So if I were to come on over here, let me get rid of that because we don't need that yet. So tangent inverse. Oh, that's been doing that all day. And I'll just go ahead and at least cancel out the 2's. I won't go ahead and rationalize it. But 1 over the square root of 3. Okay. And it's in degrees, so there's the 30 degrees. Okay. And remember, the values, all the restrictions that we have for the inverses are still going to be in play. So, for example, if you have a vector in quadrant 2, okay, it may not be giving you the answer you think. So you just want to be very careful about that. Okay. So good, good, good. Any questions about that? Okay, well, let's look at our application problem, and then we are going to be done. It says a weight of 500 pounds is suspended from a steel beam by 2 cables, shown at the right. What is the magnitude of the force on the 2 cables? So I want the magnitude for the first cable, and I want the magnitude for the second cable. Okay. So here's what I did. When I was taught this many, many years ago, there's a particular method that I like to use, and surely there are going to be other methods. If you come up with one or you'd like to investigate it, please feel free. But ultimately, I solved this using a system. Okay. I created a system of equations, and then I just solved that system really however you choose. So take a look here. How many vectors am I actually dealing with? There are 3. Each cable represents a vector. Okay, so there's 1, there's 2. Where's the third? There you go. It's the weight due to the pull of gravity. So we actually have 3 vectors. So I started out by identifying my vectors, and I used a capital letter. Let's say that capital F sub 1, that would represent the component form of that first vector. So capital F sub 2 would represent the component form of the second vector, this second cable. And then what I called this last one here, I went ahead and said this last one was F sub G. Why do you think I chose G? Gravity. Okay, there you go. In fact, of the 3, F sub G is the only one that I know right now. Can anybody tell me what is the component form of that downward vector? Oh, now we do 9.8 meters per second squared. That's dealing with meters. That's the pull of gravity. But here, we're just talking about the magnitude, so we're talking about the pounds. So 0, because it's not moving left or right. And then what? Oh, not 9.8. It would just be the actual weight. But the weight would be what? Okay. Why would it be negative? It's going down. Remember, that would represent the direction. Okay. So this problem is in pounds. So you're absolutely correct about the 9.8, but that's in meters per second. Okay. And I think if it's in feet per second, isn't it like negative 16? Where are my physics kids? Is that right? What's the conversion if it's feet per second?
Yeah, we usually just.
Or 32? It's been so long. Okay. I'm sorry, Sid? Okay. I am recording, so I am not going to say anything. Okay. I love all my teachers here at Lubbock High. There you go. I really do. I don't have anything against anybody. Everybody's laughing. Okay. All right. So here's the thing. Okay. what we're ultimately going to want to do is take the sum of these three vectors. So again, I'm looking at my physics kids. Okay? The sum of all these vectors acting upon an object at rest should be what? No? 0. Ethan is absolutely correct. Now, here's the thing. If that object that's being suspended, if it was swaying, that would be something completely different. But we're just going to go ahead and ignore that. We're actually assuming a lot in this problem. We're just going to say that it is suspended and it is not moving at all. So the sum of all the forces acting upon this object at rest is going to be 0. So here's what I'm going to want to do. I'm going to want to take the component form of the first vector plus the component form of the second vector plus the component form for the third vector, which is the actual object being pulled down due to gravity. And we're going to set it equal to 0. Okay. Well, in order to get the component form, we need two things. What is that? Well, sine and cosine is going to be part of it, so we need the direction and the what? The magnitude. But the magnitude is actually what we're trying to find. So I used capital letters here to represent the component form. So let's say that lowercase f sub 1, that's the magnitude of the first cable. Okay, so that f sub 2 is going to be the magnitude of the second cable. All right, and really when it comes down to it, you can use any variables you want. This is just what I went ahead and did because I was thinking about the force as applied by these vectors, the force in pounds actually. So let's go ahead and start there. Okay. Now, you notice one other thing I did, I went ahead and created a little table over here, and this is just something I thought I might go ahead and kind of encourage you to do. If you're having trouble with these problems, maybe a table over to the side to help you organize your information would really help out. So you could say theta, and then we could go ahead and say cosine of theta and sine of theta. Because remember, from the formula we learned yesterday, we're going to have to do that. So we need to find some theta values. And in fact, Satish just brought that up as well. Okay. So before we go ahead and find theta first, I'm just going to go ahead and write out the component forms. So the component form for f sub 1, given what I have, would everybody agree it would be the magnitude of that first cable, the first vector, times cosine theta, then the magnitude of that cable times sine theta. See, all I'm doing is taking that formula and I'm applying what variables I'm using. Is everybody okay with that? Okay. So what would the component form for f sub 2 look like? Bless you. So somebody help me out. What would the component form for f sub 2 look like, the second vector? Yeah, there you go. It's going to be exactly the same, except instead of f sub 1, the lowercase, it's f sub 2 lowercase, because that's the magnitude for this second vector. Okay, f sub 2 cosine theta, f sub 2 sine theta. And now for f sub g, that one we already know because it's straight down due to the pull of gravity. So we're going to say 0, negative 500. Okay. Now, yes, ma'am. Uh-huh. Now, theta will be the same depending on the vector. There are only two measures we're going to use. Okay, so you'll notice what I've done. Pretend this point right here is the origin. So I'm going to recreate this on my coordinate plane. So this is the vector f sub 1. This is the vector f sub 2. And then I've got f sub g going straight down, right? Okay, so the origin right here. So in order to find the two values of theta, remember, where do we start rotating from? Standard position, so the positive x-axis. So for this first component form of the first vector, I need to know what that measure is. Well, what about the diagram can help me determine that? Anybody tell me what the first value of theta is? And there's something from geometry that you have to remember. Maybe if I drew it, it would help jog your memories. What do you call a line that intersects two or more other lines? It is a transversal. So let's believe those two horizontal lines are parallel. So if this is 65, then that measure has to be 65. Okay. So the first measure I'm going to be dealing with is 65 degrees. Is everybody okay with that? Can anybody tell me what the second measure is? Now I've got to go from the positive x-axis to the second vector. So think about the transversal. How can that help me? 155. Where are you getting 155, Jack?
Oh, that would be the total, though, so you would have to...
No, you're absolutely right.
Oh, really?
Yeah, because if this is 25, then this would be 25 degrees as well, right?
Yeah.
But remember, we want to rotate all the way over. So yes, that's 155. Okay, good. So see, now I can just fill in the table using my calculator. I can just get those approximate values. Is everybody okay with what I've done? Okay. So this right here was 155 degrees. Okay. All right, so I'm going to go ahead and go around the room. I'm just going to call on specific people. The first thing I need is cosine of 65 degrees. Okay, cosine of 65 degrees. Let's go with, who haven't I talked to lately? How about Dylan? So let's go ahead. In my notes, I went ahead and took this to 4 decimal places. So let's do the same. So cosine of 65 degrees. Point what? 4226. That's exactly what I got. 4226. Perfect. And like I said, if you like this idea of kind of organizing your information in a word problem, great. If not, just something I thought I'd throw out there. Okay. Let's see. Who else haven't heard from? Raphael. Haven't heard from you in a while. I need sine of 65 degrees. Again, to 4 decimal places. 0.9063. Good. Perfect. Now I'm going to fill in the second row, so I want cosine of 155. Verda? There we go. It's in the second quadrant, so we'd expect cosine to be negative. So negative 0.9063. And we'll finish up. Juan, can you help me with sine of 155? 0.4226. There we go. 0.4226. Okay. And see, this is the way I like to work it because I've got the component form already set up. I'm looking for the magnitudes on each one. But now that I know the theta values, well, I can just go ahead and replace them. Okay. So if you want me to go ahead, maybe this would help. Let me do it this way. I'm going to go back now. I'm going to go ahead and replace my thetas with the degree measures we have, 65. And then we have 65, 155, 155. Okay. So now, as I go ahead and take the sum of these three, I'm going to go ahead and convert those to the decimal approximations that I have. Okay. Remember, the sum of all the forces acting upon this object at rest, I think, what do you call that in physics? Static equilibrium? Is that right? That sound familiar? Kind of, yeah, okay. It's been a long time since I've had physics, so please tell me if I'm wrong, okay? So f sub 1 plus f sub 2 plus the f sub g should equal 0, okay? Well, we know the component form for the first vector was this guy right here. But we also know what the decimal approximations are now. So I'm just going to go ahead and sub in. So the component form should be 0.4226 f sub 1, comma. Sine of 65 was 0.9063. 0.9063 f sub 1 plus. So that right there takes care of the component form for the first vector. Okay. Now I want to do the same thing for the second vector. Okay. So what am I going to have here for the x value? Remember, now I'm looking at f sub 2 cosine 155. There you go. Negative 0.9063 f sub 2. Because this second vector has a different magnitude that we're calling f sub 2. Okay. Comma. What would the f sub 2 sine 155 look like? 0.4226 f sub 2 plus, okay, that takes care of that one. Now we have the component version of the gravity, third vector, 0, negative 500. And that equals, now here's the question. What would the 0 vector look like in a component form? What would your A and B values look like? They'd both have to be what? 0. So I'm going to say 0, 0. Okay. Now, can everybody see where I got the idea to create a system? How do I add and subtract component forms? There you go. Take the A's and add them all up. So I'm going to take this one plus that, and it should equal that. I can take an equation right off what I've got. Then I'm going to do the same thing for the B values. Okay. So my first equation here in the system, I could say 0.4226 f sub 1 minus the 0.9063 f sub 2. Now, then we have plus 0, but that doesn't do anything, so I'm not going to worry about it, equals 0. Okay. What would be the second equation? What would I start with? 0.9063 f sub 1. What? There we go. Plus the 0.4226 f sub 2. Now we have minus 500, and it should equal what? 0. Now I'm going to go ahead and write minus 500 equals 0, but you could easily just say it equals what? 500. I mean, the equation is still going to be the same. So now you have a system. And you could solve it any way you want. I solved it in my notes using substitution. I thought that was probably the best way with the decimals. You have elimination. You've got matrices, Cramer's rule. All of those are great. But what I'm going to go ahead and do here, I don't want to take up too much more of your time. I want you to have time in class to work on your assignment. So I'm just going to turn to the calculator. This is one of those rare occasions where the calculator is just going to go ahead and do the work for me. So actually, I'm really kind of surprised. Not a lot of people knew about this today. So let me show you. If you go to your calculator, if you're on your scratch pad, if you go to menu, algebra, solve a system of linear equations. Of course, it's got to be an X and Y. All you have to do is type in your two equations, and it'll solve the system for you.
You also do a matrix, right?
Matrix, if you write it using the matrix equation. So if you write it as a system, yes. But there are other ways on the calculator to solve using matrices, whether it's by the inverse or determinants. Okay. But just go ahead and type it in. What was it? 0.4226. Now f sub 1 I'm going to have to replace with x minus, I think it was 0.9063. F sub 2 would have to be y. And then your equals button is right here below control. And then 0. Okay. They don't have to be in slope-intercept form. They don't have to be in standard form. You just type the equations in exactly as you see them. So this next one, what was it? 0.9063x plus 0.4226y. And I'll just leave it as we had on our paper, minus 500 equals 0. Okay. So there's my system. As soon as I push enter, there are the magnitudes of the two vectors. Okay. How many people were not aware of that? Really? While I'm here, let me go ahead and show you this. Do you know about numerical solve? Numerical solve will solve an equation for you. You just have to put comma what at the end. Comma x, whatever variable you're using. So, I don't know, 7x plus 6 equals 2 minus 9x. Whatever equation you want to type in. Comma x, enter. Okay. You also realize that it will find the roots of a quadratic for you. Menu, algebra, if you go to polynomial tools, find the roots. If the degree is 2, you just put in A, B, and C, and it will give you those roots. Okay. Kind of wondering if I should now not be showing you this, but like I said, if you're in a pinch, the calculator can help. Okay. Well, I guess help. It does everything, but. Now, let me go ahead and go back and finish up this problem. So the magnitude, on vector 1, 453.16, 453.16, and then the other one was 211.31. 211.31. Now, these are in foot-pounds. Okay. There you go. Okay. Anybody ever heard of foot-pounds before? Okay. If you haven't, that's okay. I mean, most of you are in the metric system, which you really should be. You could convert it if you wanted to. I'm trying to remember, 1 foot-pound is equivalent to about 1.36 joules. Again, I'm looking at my physics students. You never use that? Okay. But there you go. I mean, a foot-pound is the amount of energy that's equivalent to lifting 1 pound of an object off of the ground. So it's been so long. But anyway, that's not important. What's important is that you can solve the problem. That's what I'm looking for. Okay. Questions? F2. How I found F sub 2. So you're talking about this component form? Oh, the answer at the bottom, like how I got those? Oh, remember, that came from the system. We just solved the system, and these are my answers. Because, see, F sub 1 came first, F sub 2 came second, so the first answer has to be F sub 1. And then the second answer has to be F sub 2. So these are the 2 magnitudes I'm looking for. Okay. Anybody else? Any questions? No? Okay. When's the homework due? It is due on Tuesday, so you have plenty of time, but I would encourage you, not wait until Monday evening to look at it, because it can, get quite a bit. You've still got a good 20 minutes. Take advantage of the time. I'll be around if you have questions. Help each other. Okay, but there we go.